Saturn is not what you think. You've seen the pictures, the rings, the golden swirling clouds. Most people assume they understand Saturn. It's the pretty one, the one with the rings. A big ball of gas sitting out there looking spectacular. All of that is wrong. The rings are disappearing. The planet is not made of gas. It has no surface to stand on, but it does have a core, except that core isn't solid either. It's a hot soup of rock and metal and hydrogen all dissolved together, stretching halfway across the planet with no clear boundary between where one thing ends and another begins. And here's the strangest part. Saturn would float in water. If you could find a bathtub large enough, this planet, which is 95 times heavier than Earth, would bob on the surface like a rubber duck. This is Saturn, and you were never really taught what it is. The rings. Let's start with what you think you know. The rings of Saturn are one of the most iconic images in all of science. Galileo Galilei first spotted them in 1610 through one of the earliest telescopes ever made. But his instrument was too primitive to understand what he was seeing. He thought Saturn had ears, handles attached to the sides of the planet. It wasn't until 1655 that astronomer Christian Huygens finally figured out that what Galileo had seen were rings. A flat disk of material orbiting the planet. That discovery is now over 360 years old. And for most of that time, people have looked at Saturn and seen those rings and assumed they are a permanent feature of the solar system. Something that has always been there and always will be. They are not. In March 2025, something strange happened. Observers around the world pointed their telescopes at Saturn, and the rings had vanished. Not forever. Not even close to forever. But they were gone. What happened is called a ring plane crossing, and it occurs every 13 to 15 years when Saturn's tilt aligns in such a way that we see the rings perfectly edge on from Earth. And here's the thing about Saturn's rings that most people don't appreciate. They extend 282,000 kilometers outward from the planet. That's 3/4 of the distance from Earth to the Moon. But their vertical thickness in most places is only about 10 meters, somewhere between the height of a 3-story building and the length of a school bus. You have a structure that stretches nearly 1,000,000 kilometers from edge to edge, and it's thinner than a house. When you look at it from the side, there is nothing to see. This is not the most disturbing thing about the rings. The most disturbing thing is that they are actively falling into Saturn right now. NASA confirmed this following the Cassini mission, which orbited Saturn from 2004 until 2017, when it was intentionally plunged into the planet's atmosphere at the end of its mission. The data Cassini collected revealed that ring material, mostly ice, is being pulled toward Saturn by gravity and its magnetic field at a rate of several tons per second. Scientists call this ring rain. At that rate, the rings will be gone in 300 million years. That sounds like a long time. But in the scale of the solar system, which is 4.5 billion years old, 300 million years is about 6% of its total age. The rings are not ancient. They probably formed only 100 to 400 million years ago, most likely when 2 of Saturn's icy moons collided and shattered each other into billions of fragments. And they will not last forever. The solar system's most beautiful structure is temporary. We happen to exist at the exact moment in history when the rings are large enough to see. That is either very lucky or something to think about. What Saturn is actually made of. Set the rings aside. What about the planet itself? Saturn is called a gas giant, and that label is misleading. Yes, there is gas, but the overwhelming majority of Saturn's mass is not in a gaseous state at all. What we see when we look at Saturn, those beautiful amber and gold cloud bands, is the outer atmosphere, ammonia crystals and hydrogen at -178 degrees Celsius. Wind speeds reach 1,800 kilometers per hour. But in 2024, the James Webb Space Telescope gave us something we had never had before. Webb's infrared cameras sliced through Saturn's cloud deck at different depths simultaneously, revealing structures invisible in ordinary light. One discovery stood out immediately: the ribbon wave, a jet stream in Saturn's northern mid-latitudes. Difficult to track for decades in visible light. In infrared, it appeared as a deep, meandering current, modulated by atmospheric waves from far below the cloud tops. Saturn's weather is not driven only by sunlight from above. Something powerful is rising from within. Webb also found something unexpected at the poles. Saturn's polar regions glow with a faint gray-green light in infrared. Scientists are debating two explanations: high-altitude aerosol particles or auroral activity from charged particles interacting with the magnetic field. The answer may be both. Now go deeper. Below the visible atmosphere, pressure increases. Hydrogen stops behaving like a gas. The molecules compress until the gas transitions into a liquid, not gradually, not with a clear boundary, a slow continuous fade. Below Saturn's clouds is an ocean, not of water, of liquid hydrogen, tens of thousands of kilometers deep, deeper still. The pressure becomes so extreme that electrons are stripped from hydrogen atoms and flow freely through the liquid. This is metallic hydrogen. It looks like a liquid. It behaves like a liquid. But it conducts electricity like a metal. And that flowing current is what generates Saturn's magnetic field. Saturn's magnetic field is 578 times more powerful than Earth's, generated not by molten iron, but by liquid hydrogen. And that field holds one of the strangest unsolved mysteries in planetary science. Every planet with a magnetic field has its magnetic axis tilted relative to its rotational axis. Earth, Jupiter, Uranus, all tilted. But Saturn's magnetic field is almost perfectly aligned with its axis of rotation. The symmetry is so precise, it should not, according to our models, sustain a dynamo at all. It does. We do not know why. The fuzzy core for decades, the standard model was simple. A compact, rocky core at the center, surrounded by layers of hydrogen and helium. Clean, organized, easy to visualize. Cassini's grand finale changed everything. In its final months, Cassini performed 22 orbits through the narrow gap between Saturn and its rings. The data gave scientists an extraordinarily precise measurement of Saturn's gravitational field. By studying tiny waves traveling through the C ring, a team from Caltech, led by Christopher Mankiewicz, discovered that Saturn is oscillating. The planet rings like a bell constantly. Those vibrations carry information about the interior. The data revealed that Saturn does not have a compact core. It has a fuzzy core, a region where heavy elements, rocks, metals, and ices gradually dissolve into the surrounding hydrogen. No distinct boundary, no edge. This fuzzy core extends outward to about 60% of Saturn's total radius. Roughly 60,000 kilometers. Its mass, between 17 and 20 times Earth. It is not a solid ball, not a liquid ocean. It is a gradient. The rocks and ice near the center are actually soluble in hydrogen at those pressures and temperatures. They dissolve and mix upward, slowly, continuously. We have no word in everyday language for what this thing is, the heat mystery. There is one more problem with Saturn that scientists argued about for over 40 years. In 2024, it was finally resolved. Saturn radiates 2.5 times more energy than it receives from the Sun. Known since Voyager 2 flew past in 1981. The explanation seemed straightforward. Slow cooling from the heat of formation, Kelvin-Helmholtz contraction. But Saturn's excess heat was always too large, and the heat output wasn't constant. In June 2024, a team at the University of Houston published results in Nature Communications. They measured Saturn's energy budget with unprecedented precision across the entire Cassini dataset. The finding: Saturn experiences a seasonal energy imbalance of 16%. Saturn's orbit is elliptical. The distance from the Sun changes by nearly 20% over a Saturnian year of 29 Earth years. Near perihelion, Saturn absorbs significantly more solar energy. The planet cannot keep up thermally. It perpetually runs out of equilibrium. This 16% imbalance is confirmed as the primary driver of Saturn's megastorms, the great white spots that encircle the entire planet every 30 years. They are triggered by the buildup and sudden release of stored energy. The second heat source is helium rain. Inside the metallic hydrogen layer, helium becomes immiscible. Like oil in water, it separates and falls toward the core as droplets, converting gravitational energy into heat. These two mechanisms finally close the energy budget. Saturn is not cooling down. It is an active thermodynamic machine, still, in some sense, being born. What comes next? Saturn has 285 confirmed moons as of March 2026. As recently as a few years ago, the count was 146. The number keeps climbing because our instruments can now detect objects only a kilometer or two across at Saturn's distance. On March 16, 2026, the Minor Planet Center confirmed 11 more in a single announcement. Most are irregular satellites, tiny captured bodies in distant, inclined, retrograde orbits. Remnants of objects that wandered too close billions of years ago and never escaped. Saturn is not a planet with rings and a few moons. It is a gravitational empire managing nearly 300 worlds. Among those worlds, two stand out. Titan is the only place in the solar system besides Earth with an active surface liquid cycle, not water. Liquid methane, rivers, lakes, rain clouds, coastlines. In May 2025, JWST detected convective cloud formation directly over Titan's methane seas for the first time, the same process that builds thunderstorms over Earth's oceans. A NASA mission called Dragonfly, a nuclear-powered rotorcraft the size of a car, completed rotorcraft integration in March 2026. Launch, July 2028. Arrival at Titan, 2034. It will fly to dozens of locations across the surface, including Selk Crater, where a past impact may have created a temporary pool of liquid water in contact with Titan's complex organic chemistry. Did life begin there, even briefly? Enceladus is smaller, quieter, but arguably more urgent. Its geysers carry organic molecules, hydrogen, silica particles, everything on the checklist for a habitable ocean. The Enceladus Orbilander would orbit the Moon to sample the plumes, then land to search for biosignatures directly. Estimated cost, $4.9 billion. Possible launch, late 2030s. There is no active mission at Saturn right now. Cassini plunged into the atmosphere in September 2017 and has been silent for 8 years. Everything we know comes from that one spacecraft. While Webb watches from a distance and Dragonfly is being built in a laboratory in Maryland, Saturn itself continues to change. The rings fall in a few tons at a time. The helium rain continues. The fuzzy core slowly shifts. 285 moons. A seasonal energy imbalance discovered in 2024. A magnetic field whose symmetry we cannot explain. An atmosphere with structures we only just found. A core without a boundary. We got one spacecraft. We got 13 years of data. And the questions are multiplying faster than the answers. That is Saturn. And you were never really taught what it is.